Let's talk about exponential growth and exponential decay. Exponential growth means that something is growing day by day or hour by hour or year by year, whatever. But that's exponential growth. It's growing exponentially. We're using the x value as an exponent to make things grow according to the multiplier. And obviously, if something's going to grow, the multiplier has to be bigger than 1. I mean, if you multiply something times 1, it's just itself. 3 times 1 is 3, 4 times 1 is 4, 5 times 1 is 5, and so on. But if you multiply by something bigger than 1, say 2, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and so on. So that is why you have to have the multiplier bigger than 1 if you're going to have exponential growth. Exponential decay, you're going to have something smaller than 1 you're going to multiply by. So if you take 2 times 1/2, 2 divided by is 1. So it's shrinking. And then the next time just be 1/2. And so 4 times 1/2 would be 4, and then 1/2 of 4 would be 2, and then 1/2 of 2 would be 1, and 1/2 of 1 would be 0.5. It's decreasing every time that you have another iteration of the particular decay. So exponential decay requires a number smaller than 1. Exponential growth requires a number bigger than 1. I wanted you to have a context of that, just a way of thinking about it, because what the format for exponential growth and exponential decay is f of x equals ab. I can't draw a b. ab to the x. And so that is the equation for exponential growth. A is the starting value. And B is the multiplier, or the rate, or there's probably other names for it. But it's the rate of growth, it's the rate of change, really, the rate of growth or rate of decay. So for exponential growth, B is equal to 1 plus R. For exponential decay, I can't write. Exponential decay, B is equal to 1 minus R. And R is the percentage that you're going to be using. So if somebody says, we're going to grow at a rate of 20%, well, this 20% doesn't mean anything, does it? I mean, 20%, because we're going to have to add it, okay? So we would have, we would say 1 plus 20%. I think, well, crud, what does that mean? Well, percent really means divide by 100. So if you have something that is a percent, you have 20%, 20 divided by 100, you just move the decimal 2 places, 1, 2. We're going to be right there. 20 divided by 100 is 0.2. You can write it as 0.2 is fine if it helps you know where the decimal is, but it's just 0.2. So we would then say, I like my little equal signs here, 1 plus 0.2 is equal to 1.2 is equal to B, and that's for 20% growth. What if you're going to double the growth? What if you're going to say the growth is going to double? Well, it's going to add 1 each time because the doubling growth is equal to 2. So I'm not sure that I can use it the same. I guess I could use the same percentage. I'm not going to bother with that right now. So here we have 20%. This would be growth. This would be growth. G-R-O-W-T-H. Growth right there. Okay, so what if we had decay? So if we had a decay of 20%, can you still see this? Not very well. Let's move it up. So growth would be 1.2. Man, dirty. I need to get new erasers. That's yucky. All right, so we would have 1 minus R for decay. So we had a decay growing a 20% decay every day or every week or whatever. We would have 1 minus 20%. And 20% isn't a number yet, it's a concept. And we don't like to say, hey, I got a pay raise of 0.2. Well, what does that even mean? Well, we got tired of saying that and explaining it mathematically. So 100 years ago, somebody said, well, why don't we just multiply the point 2 times 100 and call it percent, and people will understand it more. Well, yeah, but boy, we added a little bit of complexity. So we have to take the 20 and divide by 100, and we already know it's 0.2. We covered it just a minute ago. So that would be 1 minus zero point 0.2 equals zero point 0.8. And so that is the exponential rate of decay is zero point 0.8. So what would that look like if you had it on your equation? So you need to get an idea of how this equation works. So if we had f of x equals 5, we're going to start out with 5, whatever it is, and we're going to multiply. We're just going to multiply by 2. We're going to double it every single day, whatever it is. Maybe it is our who knows what it is. We're making something to sell, and we make 5 every day, and and the next day we make 10, etc. So if I say, and my little chart here, x and y, so I'm going to start at 0, 1, and 2. So that is just a real good way to figure out more about what this thing's going to look like. So if I put a 0 in for x, I have 5 times 2 to the 0. Anything to the 0, do you know what it is? Anything to the 0 is 1. So 2 to the 0 is 1. So that means I have 5 times 1 is equal to 5. So when x is 0, before we do anything, the value is 5. Now then, let's make the x a 1. So we have 5 times 2 to the first power, and 2 to the first power is just 2. 5 times 2 equals 10. So when it's 10, look at that, it doubled. And so now let's see what it will be on the next day, which would be 5 times 2 to the second power. So that would be 5 times 2. Now, to the second power just means you have two 2's multiplied by each other together. So 2 to the second power is 2 times 2, which you should know is 4. Although I have a way to prove it's 5. That'll be in a different video. That's just a funny video. But anyway, 2 times 2 is 4. So 5 times 4 is equal to 20. And so 20. So the first day you have 5 gizmos, and the next day you have 10 gizmos, and the next day you have 20, whatever it might be. So that is a way to look at that. And there's a lot of information that is captured in here when it comes to f of x equals ab to the x. Now, if you had a decrease, say you had a decrease, and you had f of x is equal to 100 times 1/2 to the x. And we're going to have exponential decay this time. So instead of going by the wonderful increase, we're going to decrease. So maybe this is something decreasing. Who knows what it is? Bacteria in soil as winter approaches or something. I don't know. So you would have our same little chart here, x and y, to get a little idea of what it's going to look like. So when x is 0, 1, and 2, it's just a good way to do it. So when x is 0, so 100 times 1/2 to the 0. So what's anything to the 0? Do you remember? Anything to the 0 power is 1. So we have 100 times 1 is equal to 100. So when x is 0, y is 100. And look at that. That's our starting value. That is also equal to a, and that's our starting value, because this is a and this is b, the multiplier, the rate, the whatever you're exponentially increasing or decreasing. This is decreasing at a rate of 1/2. So that is when it's 0. So now let's make x equal 1. That's our next little deal here. So 100 times 1/2 to the first power equals 100 times 1/2. So what is 100 times 1/2? Well, a lot of different ways to look at it. You can think of 100 as being 100 over 1. Everything's over 1. We don't write it over that, but sometimes that helps you. So 100 times 1 is 100 divided by 2 equals 50. Look at that. It cut it in half. That's amazing. Shocking. All right, let's see what happens when I make x is equal to 2. So now I have f at x is equal to 100 times 1/2 to the x. I'm going to substitute a 2 in for that so I can fill in my little chart here. So 100 times, so 1/2 squared is 1/2 times 1/2 is equal to, do you know? The top is 1 times 1. The bottom is 2 times 2 is equal to 1/4, and it's 1/4. So this would be 100 times 1/4. And so we could think of it as over 1, so that'd be 100 divided by 4 equals 25. And do you instinctively know that 100 divided by 4 is 25? Let me give you a way to think about that. Think of 100 as 100 pennies. What's 100 pennies? It's still $1. So you have $1 divided by 4. You and 3 buddies, you're going to split this $1 4 ways. Everybody gets what? Everybody gets a quarter. 4 quarters for $1. That's 25. So just think of it in terms of money. I got $1 divided by 4. I'll make it bigger. I got $100, and we're going to split it up 4 different ways. Everybody gets $25. Whatever. 100 divided by 4 is 25. That goes here. Look at that, cut in half again. Each value cuts it in half, and it gets smaller every single iteration, whatever that might be. So that is how exponential growth and exponential decay works, very simply. We'll have some more videos on this, but this is the first video on this particular concept. Please let me know if you have any questions or thoughts. Thank you. So you can play around with exponential growth and exponential decay in Desmos to get a better feel for what's going on. So the first one we had was 5 doubling every day or every interval. So if I put here just 5 in parentheses 2 to the x, you can see the line and how it goes up. It just goes up forever. And it has, if you could also put 5 to the a and add a slider for a, and that would enable you to get various values. Like we talked about 0, if you make the exponent 0, then it gives you the starting value. And if you make it 1, it gives you just the plain ratio times the starting value, or 10. So you can play around with it and see what it's going to be like. And you can use the variable with great success. What was the other one? 100 to the 1/2. So I can get rid of these and have 100. And it is being cut in half every day, or every interval, whatever the interval is. And if I put my exponent up here as x, well, you can see that the red line starts at 100 way up here, and it goes down. It'll never quite reach 0. It gets really close. Now, your computer may say it hits 0 because your computer has a limited number of decimals it can handle. So then you can also do the same thing here with the a, 100, and the rate is 1/2, and we can put an a here and add a slider, and you can play around with it. So when a is 0, then that's your starting value, and when a is 1, that's your next value. Now you can use those values to find your rate. So if you're given a problem that just has the value at 0 and the value at 1, you can find your rate. Just divide the second by the first, and it'll tell you what we've got here. In this case, we divide 50 by 100 and have 1/2. So play with Desmos, play around with it, and get a better handle on exponential growth and exponential decay. You're going to find that concept comes up all the time in terms of math problems, etc. You got any questions? Let me know. Thank you so much.